Okay, so we're going to do inequalities. We did equations last and solving linear models involving equations, and now the same involving inequalities. So you can see this is the first slide from the last video. I just changed the word inequality highlighted in yellow. So you're writing a verbal model, substituting the values, and then solving, evaluating, or graphing the equation depending on what the question is asking, except there's different key words that are being used for inequalities. So speaking of inequality symbols and keywords, so for less than, greater than, less than or equal to, and greater than or equal to, there's certain phrases that you have to watch out for in a verbal model that indicate whether it is a greater than statement, a less than statement, and particularly a difference between a greater than and a greater than or equal to, or a less than or equal to. So in this example, none of these phrases are going to be used. I just wanted to show you them so you have them and you can reference them in your work. For instance, less than or equal to is no more than. But less than is fewer than. So is no more than implies that it can be equal to, but is fewer than implies that it cannot. Now, sometimes the context of the problem itself is what indicates less than or equal to, or greater than or equal to. So let's look at an example here. So a crane cable that can support a maximum load of 14,000 kilograms. So this is a cable on a construction site. It's moving gravel around, etc. It says if a bucket has a mass of 2,000 kilograms and gravel has a mass of 1,500 kilograms for every cubic meter, how many cubic meters of gravel can be safely lifted by the crane? So there's no is more than, is less than. None of those key phrases are associated in this model, but there is something that indicates to me in this problem whether it's less than or equal to. So let's look at the model. Once again, this is something that you're going to have to examine the problem, come up with the operations, come up with the placement of the coefficients and the variables, and look at the context of the actual problem to set up the inequality. So here's my verbal model. The mass of the gravel per cubic meter multiplied by the number of cubic meters of gravel that are actually in the bucket of the crane, plus the mass of the actual bucket itself, that is less than or equal to the max load of the crane. So how do I know it's less than or equal to and not less than? Well, a maximum load implies that, okay, you can have 14,000 kilograms inside of this crane. It's not going to be terrific to have exactly 14,000, but there's nothing that tells me that it can't be or equal to. So a maximum load, that phrase implies less than or equal to, not less than. Even though logic says, oh, do I want to put 14,000 kilograms inside of this bucket of this crane? No, well, not necessarily, but you could. It's the maximum allowed amount is 14,000. So, or equal to being 14,000 is okay. All right, so once again, this just involves some extra practice. This involves, looking at a bunch of these contextual problems and understanding, which is which, and going through a bunch of them, which we'll do, of course, in class. So, now for the substitution. The mass of the gravel per cubic meter. Is that given in the problem? Yes. The gravel has a mass of 1,500 kilograms for every cubic meter. So we have that. We know what that is. That's 1,500. There. Okay. Number of cubic meters of gravel in the bucket. Is that given? No, that's not given. You're trying to figure out how many total cubic meters of gravel can be sustained inside of this bucket. So I'm going to call that my unknown variable, and I'm going to say it's lowercase g. Mass of the bucket. Is that given? Yes. The bucket has a mass of 2,000 kilograms. What's my max load? That's also given as 14,000. It's not a decimal point. That is a comma. There we go. Okay. So now we have our model. Let's solve this as an inequality. So that's 1,500 G plus 2,000 less than or equal to 14,000. Draw my comma in here. Make that obvious comma. I'm going to erase this and try again. Sorry, peeps. All right, we're dropping the commas. Let's do that. Should we? Yes. I know I can hear the Mr. Patterson, come on. Okay, so subtract 2,000 from both sides. Get 1,500 G less than or equal to 12,000. Give you a little bit more space to work with here. Divide both sides by 1,500. Right, and by the way, like if you're seeing that you can understand the algebra involving these problems, no one's saying that you can't fast forward this video a little bit. Jump to the ending. 12,000 divided by 1,500, that's 8. These cancel, right? The 1,500 over 1,500 cancels, G is left. So G less than or equal to 8. So what does that mean in the context of the problem? Remember, don't just leave the equation or the inequality with the algebraic outcome. We need to write something contextual about this problem. Answer this. It doesn't have to be a complete sentence. Of course it can. But in this case, you want to say, okay, the number of cubic meters of gravel in the bucket can be less than or equal to 8. So I'm going to write 8 cubic meters oops. I'm gonna get better at writing with this. Promises. I'm gonna write 8 cubic meters of gravel. I lost my J. Speaking of J, OMG. Why can't I write with this? Oh my gosh. I'm not going to write. Okay, 8 cubic meters. Or so let's just understand that it's of gravel or less. So the or less is important because that implies that it could be 8 cubic meters, but it's also potentially less than 8 cubic meters. So what this means here is, and this is essentially my final answer, 8 cubic meters or less. I'm going to circle it in green. This is my final answer. That means that I could have 7 cubic meters, 7.5 cubic meters, 6 cubic meters, etc. Right, okay. So remember, context clues that tell me less than or equal to. That's pretty much the most difficult part about inequalities. And you're solving the inequality in the way you know after you set it up. But the verbal model is the hardest, but we'll have some practice with that. Okay, so that is solving linear inequalities by using or models of linear inequalities by using a verbal model.